Hello, in this video we're going to be dealing with the vertex form of a quadratic. Currently we've been using the standard form of a quadratic, where we have y is equal to ax squared plus bx plus c. So our x's are in descending order. Exponent of 2, exponent of 1. If I had an exponent on this, it would be 0. Also notice that we've talked about if a is positive, then your parabola opens up. If a happens to be a negative number, then your quadratic opens down. We've looked at the constant, and the constant happens to be your y-intercept. Okay, so that's what we know about standard form. Vertex form is a little bit different. Now these are mathematically equivalent. If you were to rework one of them, you would get the other one, and vice versa. What I want to talk to you about today is the vertex form. So here's your vertex form, where you have the same a as the a in the standard form, but what you have here is hk, and the h and the k make up our vertex. Now notice this is a minus h. That's going to make a big difference for us. Okay, so if we look at the first one here, this is a negative, which means this parabola is opening down. I can get my vertex from here. So if it was minus h, then your h value must have been 5. Your k value is 5. So this has a vertex of 5, 5. Let's see if we can identify the vertex of each of these. If it was minus k, to get a positive 4, it must have been a negative, because only a minus would give me positive. And then my y value is actually 2. My y value or my k value. So this is h, this is k, but it makes up an ordered pair. All right, let's take a look at the next one. Your h value is 1, which is also your x value, and your k value is negative 2. The vertex in this one, to be a plus, it must have been a minus, so that would be negative 3, comma, negative 7. In this one, your h value is 6, your k value is 11, so your vertex is at 6, comma, 11. And in your last one here, to get the plus, it must have been minus, so this is 10, comma, 5. Now, what I like about this form, and I'm going to show you another example here, what I have over on this slide is I actually have our parent function. So this is our parent function, y is equal to, y is equal to x squared. Now, what's cool about this is you can look at your transformations. So for example, if we look at this first problem, I notice that the leading coefficient is negative. And what that's actually going to do is that's going to take this and it's actually going to reflect it. So I'm going to flip this upside down. Let me bring it right down here. Now, this, if you remember, the minus 5, when you have a transformation inside the parentheses, that impacts your x values. So what this means, and if you remember what I said when we were talking about transformations, what makes this 0? Well, positive 5 makes it 0. Therefore, this goes positive 5 on the x-axis, which is right 5. So that means I'm going to take the whole thing and I'm going to move it right 5, and when you do a plus 5 on the outside, that means up 5. Therefore, your vertex is 5, comma, 5. And if we take a look, I'm going to take this right here, and I'm going to go right 5, and then I'm going to go up 5. Boom. There's your parabola. Okay, I'm going to put this back to where it was, and we'll look at the next one. Let me flip this back upside down. All right, so I'm going to put this back. Now let's take a look at our next one. This, you have to look at this and say, okay, what makes this 0? Negative 4. That means this goes left 4, and the plus 2 on the outside means up 2. So that means I'm going to go left 4, 1, 2, 3, 4, and up 2. There's your parabola. Kind of nice. Let's keep it going. On this one, the minus, what makes a 0 is positive 1. That means this goes right 1. And then it's a negative 2 on the outside, which means we go down 2. So I'm going to put this back at our parent function right here, and I'm going to go right 1 and down 2. That's where your parabola should be. Okay, continuing on, we'll do just a couple more and then we'll just move right on here. So what makes this 0 would be -3, which means this goes left 3 and this goes down 7. So that means I'm going to go left 3, so to the left 3 and down 7. So to the left 3, down 7. That's where your parabola is going to be. The next one, x minus 6, you're going to look at this and say what makes this 0, and that's going to be a +6, so that means I go right 6 and I go up 1. And I think we'll end with that one because I think you get the point here. So this one's going to go right 6 and it's going to go up 1. I love how the transformations work so well with vertex form. But one of the things that we have to be able to do is get the vertex form. So one of the goals that I have for you today in this lesson is to change from standard form and make it into vertex form. Okay, and vice versa. I want you to be able to go back and forth. The way we do this is actually use the process of completing the square. Now what's cool about using the process of completing the square is that we don't actually do the entire completing the square. We just do part of it, because we only want to get it to the point where we have this binomial squared. You still want to get y all by itself, but you want to get that binomial squared. So let's take a look at example number 1. If you remember from completing the square, we're going to make this a perfect square trinomial, which means we should move the -10 over to the other side. So I'm going to add 10 to both sides, and I get y plus 10 is equal to x squared plus 4x. Now I'm going to look at this and I'm going to say, okay, what constant makes this a perfect square trinomial? So to do that, if you remember, what we're going to do is we're going to look at that linear term, which is 4, and we're going to say, okay, half of that is 2, and then you're going to take that and square it. So you take half and square it, half and square it. So that means we're going to add 4 to both sides, because remember, it's still an equation. Whatever you do to one side, you have to do to the other. Okay, so on this side I end up with y plus 14, and on the other side I end up with perfect square binomial here, which is x plus 2 whole thing squared. Now normally we're looking to take the square root of both sides, but that's not what we're going to do here. All we have to do is move the 14 over. So we're going to put the 14 back, and we end up with y is equal to x plus 2 binomial squared minus 14. And with that, the vertex then is actually, keep in mind, this means move it left 2, so that means your vertex is -2, comma, and this would be down 14, so -14. And there you go. There's one of them. Let's try this again. Okay, in this problem, you'll notice I have a negative. Now that negative is going to be very important, and I want to draw your attention back to your standard and vertex form here. This a is the same as this a down here. So that means if this a is a -1, then when I'm all done, I'm going to have a negative out in front of those parentheses. So if you remember the process for completing the square, your leading coefficient has to be a +1. So that means I'm going to have to divide everything here by -1. And whatever you do to one side, you have to do to the other. So I end up with -y is equal to x squared minus 6x plus 5. Now I have to get a perfect square trinomial, so I have to make this a perfect square. I'm going to minus the 5 from both sides. So I get -5 minus y is equal to x squared minus 6x. So now I have to look at this and say, okay, what makes this a perfect square? I look at that -6 and I say, okay, take half of that and square it. So if I take half of that and square it, I'm going to get half is 3, -3. -3 squared is +9. I'm going to add that to both sides. So now I end up with 4 minus y is equal to x minus 3 whole thing squared. Now I'm going to bring that 4 back. And I get negative y is equal to x minus 3, whole thing squared, minus 4. Now I have a couple options here. I have to get rid of this negative out in front of the y. I can do one of two things. I can multiply both sides by negative 1, or I could divide everything by negative 1. If I divide everything by negative 1, this is a term, there's a term, and I end up with y is equal to, now what I'm going to do is I'm not actually going to touch the binomial. I'm going to put the negative just out in front. Okay, so imagine this like a negative 1 divided, or a positive 1, excuse me. And I do positive 1 divided by negative 1. That's going to give me a negative 1 out in front. I don't care if you write it as a 1 or not, it doesn't matter. So essentially our answer here is y is equal to negative x minus 3 binomial squared plus 4. Now, my vertex is going to be 3, 4. Let's try another one. Ooh, I like this one, and I'll tell you why I like this one. I don't have a constant to move. So I can just look at it just the way it is and say, okay, I'm going to take half of that positive 6, which is positive 3, and square it. 3 squared is 9, so I'm going to add 9. Whoops, excuse me, I don't know what that was, but I'm going to add that to both sides. So I get 9 plus y is equal to x plus 3, whole thing squared, and now all I have to do is move the 9 back. So I get y is equal to x plus 3 binomial squared minus 9. So therefore my vertex, now if this is a positive 3, remember, what makes this 0 would be negative 3. This actually goes left 3. So what we have here is a negative 3, because we're going left 3, and the negative 9 on the outside means we go down 9. So negative 9. Okay, let's try another one here. Uh-oh. This one looks kind of ugly. The reason that it's ugly is that we have a leading coefficient of 3. It has to be a positive 1. So I'm going to have to divide everything by 3. And I have to do it on both sides. So I'm going to get 1/3 y is equal to x squared minus 4x plus 5/3. Okay, I'm going to move the 5/3 over, and don't be tempted to change it to a decimal. Just leave it as a fraction. It typically works out just fine in the end. So we have negative 5/3 plus 1/3 y is equal to x squared minus 4x. All right, now we're going to take half of negative 4 and square it. So half of negative 4 is negative 2. Square that, it's 4. So I'm going to add 4 to both sides. This side's easy, so this is x minus 2, the binomial squared. Over here, let's see, 4 minus 5/3. So I'm going to rewrite this with the denominator of 3. So 3 times, let's see, whoops, yes. So I'm going to have to multiply both top and bottom by 3. So that makes this 12/3 minus 5/3. Looks like 7/3. So I get 7/3 plus 1/3 y is equal to x minus 2 binomial squared. Now I'm going to bring the 7/3 over by minusing it. So I get 1/3 y is equal to x minus 2 binomial squared minus 7/3. Now here's where the fun happens. I have to get rid of the 1/3. I can't leave it that way. I have to solve this for y. So to get rid of the 1/3, I'm going to multiply everything by 3. And here's what that gives us. That gives me, those cancel, y is equal to 3 times parentheses x minus 2 binomial squared. Those 3 cancels, and I get negative 7, which means your vertex is 2, negative 7, because this actually shifts that Let's see, that's going to go right 2, which makes this a positive 2 here, and this is going to go down 7, which makes it a negative 7. So we are good. Great. So that's using the process of completing the square. Now, a couple things that I want you to notice. Again, this 3 is the same as the 3, same as the leading coefficient there. The other thing that I want you to pay attention to is if I asked you to go the other way, in other words, start with vertex form and give me standard, that's easy. All you would do is you would FOIL that, multiply it by 3, and then minus 7. So basically you would be, it's like simplifying this right here. So you would multiply it all out and combine like terms. And that's how you go from vertex back to standard. Now I want to talk to you about using the key features. Now here's the cool part. If I give you vertex form, some of these key features are a piece of cake. So your vertex here is going to be 7, comma, negative 1. Now if you remember, okay, so your vertex is 7, negative 1. That's going to be somewhere around here. Okay, so if that's 7, comma, negative 1, keep in mind your axis of symmetry goes right through the middle of that, which means your x value is going to be the same as the x value in your vertex. So that means your x value is 7, so your axis of symmetry is x equals 7. That's very cool. Your y-intercept, keep in mind on the y-axis, something's always true on the y-axis, and hopefully you remember that x is 0. So I'm going to take my equation and I'm going to put 0 in for x. So that's going to be 0 minus 7, whole thing squared, minus 1. Might be able to do this in your head. So this is going to be what? Negative 7? Negative 7 squared is 49, minus 1. So your y-intercept is actually 48. Your x-intercepts would be here and here. And what's true on the x-axis is that y is 0. So I'm going to take my equation again. And I'm going to put 0 in for y. Now, if you wanted to, you could rewrite this in standard form and try and factor it. I wouldn't, because there's something very special about the way this is written. I can actually bring the 1 over, and I have 1 is equal to x minus 7 binomial squared. And the opposite of squaring is actually square root. So I'm going to take the square root of both sides. And remember, the square root is finding one of two equal factors. So my equal factors here are x minus 7. On this side, I don't know, so I'm going to say plus or minus 1. Now, to solve for x, I just bring the 7 over. So x is equal to 7 plus or minus 1, which means I have two answers. 7 plus 1 means x could be 8. 7 minus 1 means that x could be 6. So it actually crosses at 8 and it crosses at 6. Let's try this again. All right, here we have another one. It's in vertex form. So let's get the vertex out of there. So the vertex would be negative 2, comma, negative 14. Keep in mind that this, if you use your transformations, what makes a 0 is negative 2, so that means this is going to go left 2, and this would go down 14. So that's negative 2, negative 14. Your axis of symmetry, this point, your vertex is right on the axis of symmetry, which means your x value is the same. So x is equal to negative 2. Your y-intercept, all you're going to do is you're going to put 0 in for your x value. So now we get, let's see, 2 squared, which is 4, so 4 minus 14. So that means your y value here is negative 10. Okay, now to get your x-intercepts, you're going to put 0 in, but you're going to put 0 in for y. So if I put 0 in for y, I get x plus 2, the binomial squared, minus 14. And all I have to do is bring the 14 over, and I get 14 is equal to the binomial x plus 2, whole thing squared. The opposite of squaring is square root. Square root is finding one of two equal factors, so over on this side, one of those two equal factors is x plus 2. On the other side, it's plus or minus radical 14. And then I'm just going to bring the 2 over, so I end up with x is equal to negative 2 plus or minus radical 14. Now this is acceptable as an answer. I'm completely fine with this, especially since they did not give us a rounding place. But for those of you who maybe want a decimal, we're looking at two irrational values here. So one of the values would be 1.74. The other x value would be negative 5.74. Now there were no directions on what to do, so I'm providing both of them for you. Okay, last one. Uh-oh, have a little bit of a problem here because this is in standard form. So let's change this. Let's put it in vertex form first. So I have negative y is equal to x squared minus 6x plus 5. I'm going to bring the 5 over. So I get negative 5 minus y is equal to x squared minus 6x. Now I have to make this side over here a perfect square trinomial. I'm going to take half of the negative 6 and square it. So half of negative 6 is negative 3. Square that, I get 9. So what I end up having is 4 minus y is equal to x minus 3, the binomial squared. I'm going to bring the 4 back over, so I get negative y is equal to x minus 3, whole thing squared. Whoops. And then I'm going to divide everything by negative 1. So let me put this up on the top. So my vertex form is y is equal to negative x minus 3 binomial squared plus 4. Therefore, my vertex is going to be 3, 4. My axis of symmetry is right on that, goes right through that vertex. So that means your x value is 3. Your y-intercept, now the cool thing about this is I actually have both equations, so I think I'm going to use this one. And I'm going to put 0 into the original because I think it's a little bit easier. So essentially that's 0, so your y value is negative 5. And your x-intercepts, I think I'm going to use this equation. I'm going to put 0 in for my y value. And I'm going to show you one cool thing that you can do. I think I'm going to add the binomial to both sides. Perfectly fine to do that. Those cancel, and I'm left with x minus 3, whole thing squared, is equal to 4. I'm going to take the square root of both sides, and I get x minus 3 is equal to plus or minus 2. So let's add 3, and I get x is equal to 3 plus or minus 2, which means x could be 5, or is 5, and your other answer is x is 1. Now, the cool thing that we can do is we can take all these things and we can put them on a graph to graph our parabola. So I'm going to do that. Let me enlarge the screen here. So my vertex is 3, 4, so I'm going to go over 3, up 4, plot that. My y-intercept is negative 5, I'm going to plot that. So I'm just taking these things, and my x-intercepts is 5 and also 1, and that gives me plenty of information to graph my parabola. And there we go. So what I want you to do is I have a couple of these that I would like you to practice. So I would like you to spend 15 to 20 minutes on the practice worksheet. You can find that on my website. Good luck. Contact me if you need any help.